Hello, students. Okay, we have just one more topic to cover in this series of videos. In the last two videos, you learned how to expand expressions containing brackets, and now we're going to learn the opposite of that, which is called factorizing expressions. Now, the first thing you have to recall, you've learned this already in primary school, is if you have two numbers, well, two or more numbers, in this case, two numbers, 10 and 5, what is the highest common factor of that, or HCF? Well, the factors of 10 are 10 times 1 and 2 times 5, and the factors of 5 are just 5 times 1. So the highest common factor is the largest number that's a factor of both 10 and 5. Now, the easiest way to do this, well, sometimes you can just see the answer because you know your numbers and factors very well. But if you're not sure, my suggestion is start with the smallest number and find the factors of that, and then check to see if those numbers are also a factor of the other number. So in this case, I'm going to start with saying factors of 5 are 5 and 1, and choose the largest of those 5. Yes, 5 is also a factor of 10, so therefore 5 is the highest common factor. Out of 12 and 18, again, start with the smallest number and say factors of 12, start with 12 times 1. Well, 12 is not a factor of 18. Then go to 2. 6 times 2 is 12. So 6 is a factor of 12. And 6 is also a factor of 18. And therefore, the highest common factor is 6. Looking at these two numbers, again, we start with the smallest number. Factors of 12 always start with the number times 1, so 12 times 1. But 12 is not a factor of 28. 6 times 2, well, it might be, look at the biggest number, sorry. So 6 is a factor of 12, but that's not a factor of 28. So 6 isn't a common factor. And then we can say 4 times 3. So 4 and 3 are factors of 12, and 4 is also a factor of 28. So therefore, that's the highest common factor. The last one, 16 and 27, well, all the factors of 16 are even numbers. 1 times 16, 2 times 8, and 4 times 4. And none of those numbers can be factors of 27 because it's odd, except for 1. So I should have said all the factors of 16 are even numbers except 1. And therefore, the highest common factor of 16 and 27 is 1. Okay, now we can do the same thing with algebraic expressions or algebraic terms. So 10 times x and 15. We're looking at the numbers to start with. And again, starting with the smallest number, 1 times 10. Well, 10 is not a factor of 15. 2 times 5. 5 is a factor of 15. So the highest common factor contains a 5. There's a factor of x there, but there's not one there. So that's the highest common factor. Looking at 12a and 18b, starting with the numbers again, and looking at the smallest number, 1 times 12. 12 isn't a factor of 18. 6 times 2. 6 is a factor of 12, and 6 is a factor of 18, so 6 is a common factor. And that's got a factor of a, that's got a factor of b, so therefore 6 is the highest common factor. Okay, down to the third one. Effectively, you've got to do 3 steps on this. First, you look at the numbers. Then you look at the variable c, and then you look at the variable d. So effectively, you got to solve 3 problems in one. Looking at 6 and 8, the smallest number, 6 times 1. 6 isn't a factor of 8. Also, 2 times 3. Well, 3 is not a factor of 8, but the 2 is. So the highest common factor includes a 2. Now here we have 2 c's, c times c. Here we have 1c. So 1c is the common factor. You can't say c squared because this term, this expression here doesn't contain a c squared. This contains one factor of d, this expression contains two factors of d. So once again, what's common to that is one factor of d. So the highest common factor is 2cd. And once again, we had to virtually look at the highest common factor of 6 and 8, then the highest common factor of c squared and c, and finally the highest common factor of d and d squared. Okay, looking at the last one, starting with the numbers, I think I'll start to do these a bit faster now. I think you probably have the hang of how to do it. 24 and 21, the highest common factor of those two numbers is 3. Okay, looking at the factors of a, I've got 3 factors of a there, a times a times a. 2 factors of a there, a times a. So that contains 2 factors of a, plus an additional factor. That contains 2 factors of a. So therefore, a squared is the common factor. Okay, this is b times b, and that's b times b. So both of these terms contain b squared. So that's part of the common factor. And this term here contains a single c that contains c times c times c times c, 4 c's. So common to both of those is a single c. So c is a factor of that expression, and c is a factor of that expression. And there we have it. There's the highest common factor of those two fairly scary looking expressions. Okay, let's go ahead and use all of this to factorize algebraic expressions. Okay, so what I'm going to do, I'm going to go back to cups and beans again. Whoops, let me just turn on something. So, use the cups and beans to show 2y. Well, that's y plus y. Each of those cups contains y beans and 6 additional beans. Okay, so that's 2y plus 6, and that's what's called the expanded form. Now, I want to share these equally between 2 people. So what I'm going to do is split them equally into 2 groups. Well, that means the first person gets 1 cup, and the second person gets 1 cup. The first person gets 3 beans, and the second person gets 3 beans. So we have to share them equally. So what I have now are 2 groups, each containing y beans in the cup plus an extra 3. And that's called factorizing. The reason it's called that is numbers that you multiply together are called the factors of the larger number. So in this case, 2 is a factor because I'm multiplying it by y plus 3 in brackets, and therefore y plus 3 is also a factor. So that's called the expanded form, and that's called the factorized form. And when we change from expanded form to factorized form, that's called factorizing. Okay, let's try another one. So I've got 3 cups, each containing Z beans, and I have 3 extra beans. Now we want to just split these into equal groups. Well, I can't split them into 2 equal groups because I don't have an even number of cups or an even number of beans, but I can split them evenly into 3 groups, like so. So 3z plus 3 can be written as 3 groups, can be written as 3 groups, and each group contains 1 cup with Z beans plus 1 additional bean. So 3z plus 3 can be rewritten in factored form or factorized form as 3 times in brackets z plus 1. Once again, that's called the expanded form, and that's called the factored form or factorized form. Okay, and the last one. This time I've got 4 cups, each containing Z beans, Oh, that's not quite the last one. I have one more page to go, and 8 additional beans. So I'll just drag them out fairly quickly. 5, 6, 7, 8. So there we have 4z plus 8. Now it turns out I can split these into groups a couple of different ways. So one way I can do it is to have 2 cups in that group and 4 extra beans. And in the other group, I'll just put these closer together. And in the other group, I can also have 2 cups and 4 extra beans, like so. So I've grouped them into 2 groups, and that means 4z plus 8 can be rewritten as 2 groups, each containing 2z plus 4. But it turns out there's another way to split the beans. I could also create 4 groups. So each group is going to include 1 cup and 2 beans, like so. Hope Mr. Bean isn't getting too dizzy here, being dragged around like this. So this time I've got 4 groups, so I can write the factor 4, and each group contains just 1 cup containing Z beans plus 2 extra beans. So it turns out 4z plus 8 can be factorized in 2 different ways. And out of those 2, the one that you would see in the back of the textbook is that one. And the reason being, this is called factorized completely. If you look over here, 2z plus 4, we still have a common factor of 2 in each of those terms. So that one's factorized, but not factorized completely. So what we have to do is take out the highest common factor. So when you factorize, take the highest common factor and put that out in front of the brackets, and then figure out what's left behind in the brackets. Okay, and this is the last slide. Explain why 4y plus 15 can't be split into equal groups. Now, if you're looking at those 2 terms, there's no number that's a factor of both 4y and 15 except for 1. And if we have all these cups and beans in one group, that's not really called splitting them into equal groups. So in this case, if you're asked to factorize that, you just get 4y plus 15. In other words, it can't be factorized. It's already written in the best factorized form. You could put a 1 outside of it if you absolutely had to, but normally we don't bother doing that. We just write it as it comes. Okay, we'll stop there, and in the next video we'll actually go ahead and factorize algebraic expressions.